The second part is you will implement another important part of the operating system. There's a file system. What kind of file system? No, never. That's the reason you're here. Anyone? NTFS is most popular in Windows, right? That's the old one, FAT32 and the 16, and also Windows and the Linux, ext2, 4, something, whatever the number, UFS, GFS, NFS. There are a bunch of different file systems. What is a file system? It's a system for files, right? Oh, really? So, because we have a bunch of files, we need something system program to manage such a file. That is the file system. So, in this class, we'd like to implement file system by ourselves. The very basic, simple file system. Okay, who knows? If your file system is so good, you can sell it to the Microsoft. So that is the second part, using Google Cloud Virtual Machine also. So which means you need to use. At that time, I'm going to allow to use the Java, but may not be easy. So I strongly suggest to use. So graphical user interface, there's no benefit. So it's not required. Just the algorithm and the performance itself. So you will get the more information from the GA and me throughout the semester for these two projects. If you would like to know the more about, it's already in the Canvas. In the Canvas, I upload all the file, including PPT file and this and everything. I'm not going to provide handout, okay? Because right now it's a really hard time for the department because of the budget. So I'm not going to provide the printed handout. I can find from the Canvas. For undergraduate student, only the first project is required. Second project is extra. So if you want to do the second project, it's just extra point. It's huge. Okay. So if you do not have the enough score, midterm final, but if you want to catch up for undergraduate student, try the second project also. Okay. But graduate student, both of them are required. Okay. Any question? Yes.
Project weightage in the PPT.
Project what?
Project weightage.
Project.
In the slide which you have shown, it doesn't include the project weightage.
In wait.
He said it doesn't matter.
Which one? Did I show you anything?
Scroll up.
The grading policy.
Oh, you mean the grading policy?
Yes.
Don't worry about the grading policy. Okay, that's 10 years ago. So sometimes if I feel so good, then I can assign the one more project. So don't worry about too much grading policy and grading distribution. Okay, then before we start, that's pretty much done. Before we start, two things. To survive in this class, there are two things. No lag, okay? That's because I have too many students. If I have 5 to 10 students, then looks like a family. I like the big family, but there's too many family members. So you need to help me. So if I have only few students, I can hear all the situation and everything. So you have the girlfriend, so you need more time. So okay, so you can take a time. But so this semester, to be fair with all other students, any submission, no late. Okay. So I already gave the couple of the days without penalty. So most of the due date is a Friday, but allow until the Sunday if you already checked the due date. Okay, but it's without penalty. So you are able to submit until the end of the weekend. But after that, so no excuse. Okay, and attendance is the same thing. As I said, I'm not going to check the attendance. Instead, you need to take the pop-up quiz that will be automatically considered as the attendance. But the only exception is the medical proof by your medical doctor. That's the school policy, not my policy. So you're the absent, to excuse any absent the class, the only really. So it's a medical excuse. Okay. Otherwise, you need to submit the petition like the temporary leave. Okay. So in case it's just surprisingly a lot of students got the family issue or mental issue in the semester. I believe you, but that cannot be excused. Okay. But if you really had a problem, medical issue at the time with the proof of your doctor, it can be. Otherwise, there's no excuse of the late or the other thing. Okay. However, I do not blame you if you miss the class or anything. It's your responsibility. So I believe the Professor Lee is horrible, so I don't have to take the class. I can study by myself. I respect your decision. So you are a graduate student, so I believe you are undergraduate. You are the college student, so you are pretty much adult. You can drink. No? You cannot drink officially? No. So it's a different age. In my home country, it's lower than. But I believe your decision. For example, one of my colleagues, the friend, when I was in the PhD program, he was from the Turkey. Then beginning any class, he met the professor. Then he said, I can do the whole classwork by myself. Then to get the excuse, he submit all the material and by himself. Then he cannot get the A+ because some of the professor checked the attendance, but he accepted such a thing. Then he passed the whole class. Actually, he got the master degree within 11 months. It is possible. 4 classes. 4 spring, summer, fall. Summer there's no limitation. So he took the 4 classes. So the total 11 classes got the master degree. Then do the PhD program with me. So it's your responsibility, but do not ask the excuse. Okay, you probably heard about that. The Professor Lee is horrible to get such an excuse, and no copy. So this is crime. Okay, so I know nowadays there are a bunch of different ways, and sometimes a very smart way to copy, or sometimes buying even the classroom project from the website. That's a waste of your money. That's a waste of the parent or the family money. Okay, your time. So I don't think that will be temporary and just a moment it help you, but I don't think that will help. I'm not a god of to catch such a thing. I will try to do my best with my GA. Okay, to catch. There's no warning, there's no excuse. If I catch any copy or plagiarism or any suspicious thing, including the exam, it will be automatically I'm going to report to the department directly. Okay? Then if you, sometimes, maybe something issue or reason, you can submit a petition for that to be excused. So please, don't try. So try to enjoy. So some of the students are really serious of I understand the grade. Okay. However, that doesn't mean it can be excused because of your serious situation for the plagiarism. Okay. So the more important thing is whether you can steal my knowledge in the class. You should learn. You should get something. You pay a lot in this classroom for this class, right? So I was the same situation. it's almost 20, not 20, 15, 16 years ago, I was in your seat as a student. So even at the time, I had my family, my wife. So if I steal something, it was much simpler to survive here. But I don't think that can be the success of my life. So please, so don't even think about such a copy of other things. Do not think about shortcut. The no pain, no gain, that's true, I believe. Okay? I know that some of you guys are very new the certain program language or task, but if you spend more time, it will be rewarded. So please keep in mind such a thing. Okay, so let's start. Any question? Okay. Yes.
So the first project is about like Google being on Google Drive.
We will explain the details later for the each project. Okay? Because you raise your hand, what is this?
Square.
Square. I don't think it's a square. Even though my drawing is horrible, it's not like the square. It's a rectangular. Even though it's not the right. Who took the my course before? So what is this?
A computer.
This is a computer. So from now on, whenever I draw this one, this will be computer. This is very important. Why? What is your major? Any computer engineering? Oh no. So that's good. So all computer science. So our major, even my major, is purely the computer science. I didn't took any course or the program, the computer engineering. That is my little bit the shortcut. I do not understand fully the hardware part or the something device and embedded system. But this is the computer which we are dealing with in this major. Computer science, computer. So what is a computer? Device. We have a bunch of device. So even this is the device, right? So computer is, you took my course before, what is a computer?
It's a machine that we can.
Before that, I answered
Converts machine and machine.
what is a teacher?
Computation.
Teacher, a person who teaches. Then computer, a person who computes. But it's not a person everybody knows. So computer is starting from the compute something to have the human being. So human being historically we try to compute a lot of things from the 4,000, the 5,000 years ago. So for example, what is the name of the river in Africa? Starting the civilization, Nile River. Okay, the Nile River. So it's a good or bad for the agriculture. It's very good, right? Why? Every time flooding, then after the flooding, there is a few fully fertilized area around the Nile River. So because of that, it's the starting of the civilization. Then, so more people, and start the government and so on, right? Then so it's good to live over there. Then problem?
Flood.
Yes.
Flood.
Flood. It's really flood. So this is my land, this is your land, and after flooding, how do you know? So they need to calculate. So that's the starting of the geometry. So if we need just a triangular inequality of what is a trigonometry, then simple equation we can do with the finger. But that's not enough. The more money we have, or the bigger land we need to calculate, it's not big enough. The human brain. If you were there, probably because you are a genius, you can do that, but most of people cannot calculate such a thing. Then people start make something machine to have human calculation. One of the example of the oldest such a device is
Yeah.
abacus. Abacus. So in the, is it China only? I think there is somewhere. So abacus, like the something, yeah, stone and like that. I learned that when I was in the really in my math class, the elementary school. I was horrible. But the abacus is one of the example, and Leibniz. And I do. If this is the undergraduate class only, I can show a lot of the picture and something like that. But you can just Google the old calculator. There are historically a lot of them. However, we do not say those are the computer nowadays. So nowadays, when we are talking about computer, is still calculate something, compute something, but it's somebody already mentioned electronic device. Electronic device means with power of electricity. Then we calculate. We have the computation. So then. So 1947, 48, in the University of Pennsylvania, UPenn, made what? ENIAC computer. Do you remember the ENIAC computer? No? Anyone who heard about the ENIAC computer? I think it's a good time to offer the history of computer. If you take any other subject, they offer history of something. History of math and the history of psychology, history of something. But I wonder why we do not have the history of computer class. So, are you going to offer? So, if we have. Anyway, so ENIAC is kind of first generation, first computer, electronic computer. So it's developed by the UPenn. So because the couple of weeks ago when I visited DC, Washington DC, I stopped by the Pennsylvania. Then I saw the sign. It's the first ENIAC computer next to the School of Engineering building in the UPenn. But anyway, so ENIAC is the first computer. Then, what is a different abacus and such an electronic device, computer? First, common thing. It can represent something number, right? I do not remember exactly how to represent the number, but using change the position of this stone, it's a stone or a marble, so we can represent the very complicated number, high digit number. Then, what about this one? Your computer. It can represent the number using what? This is a 1, this is a 0, just on and off. So, if you already took the engineering class or electrical engineering, we can, what is this, pulse? 1, 0, 0, 1. We can represent at least 0 or 1 using electricity. Then, what is this? Bulb. So especially vacuum tube. So using this bulb, we can represent the same thing, 0 or 1. It's a starting of such an electronic device. So because of that, so first time the first computer like the ENIAC, its size is huge, almost the one side of this room, really. That's the. If we had 1,000 million of that computer, it will be the same as nowadays. So, using this, we can represent 0 or 1. Any computer nowadays, your cell phone, no matter how much expensive your cell phone is, or how much expensive your laptop is, it is based on what? Binary, 0 or 1. Okay? This story will be the same as any introduction of my class, the database, data mining, whatever. So this is a binary. It's based on the binary. So then it will be IC, integrated circuit, and the VLSI, and so finally we have the chip, high integrated chip. But it's the same idea, 0 or 1. Computer can understand the 0 or 1. Then, who can, oh, by the way, using 0 or 1 binary number, how can we do the programming? How can we draw the picture or take the photo? How can we do that? Using only the 0, 1. Computer can understand only the binary number. Then you can do a lot of computation or a lot of things. How? Compiler is one of the tools we can use. It's a data structure. So you already took the data structure class in your graduate? Undergraduate. You should take. So most of the data structure class is freshman level or sophomore level. Why? Because this is the clue how we can use the binary number for the computer. Okay? How computer use binary to represent a very, very complicated thing or task and so on. So it's kind of organizing. So we already know the binary system like the 0, 0, 1, 1. What is that? It's in terms of a decimal, this is 1, 2, 4, this is 7. Okay? And if we agree, 7 means L, for example, not sure. So we can represent the L using 1, 0, 1, 1. Or 4 birds of this we can represent. For example, 1, 1, 1, 1 is the E. Then we can represent the LEE using this binary number. Okay? At that time we need something agreement. That is called code. For example, ASCII code. You heard about the ASCII code? ASCII code is the all people agree the standard agreement of binary to the something alphabet and number. Then using this agree, so we can do the 1 plus 1 is what? So we can 1 is 0, 0, 0, 1, and the plus is something, and the 1 is then computer can understand what you are saying, what you ask. Okay. Then finally, this computer should have first what? Calculate this kind of thing. So that is CPU. So computer has the CPU. That's different from the other just the device. So CPU, what is a CPU? Central Processing Unit. What is the main job?
It is the brain of the computer.
That's the exactly same answer as what my daughter answered when she was 7 years old. Really? So I'm surprised. Nowadays, in kindergarten, they teach what is a CPU. She answered this is kind of brain of a human being. It's a computer has the brain, human brain. It's a calculate, compute. Compute what?
Any process given.
Any process,
Mathematical logic process.
automatic. Sometimes it's called a processor. Okay? This is a processor. So, process what? Calculate, compute what?
Data.
That is the
In.
instruction. Instruction is the very, very basic level of operation. Okay? That is designed based on the binary number. For example, 1111101 is plus. Or the 11100, it's not true. I just randomly, right? 111 is the copy or move, change the value. Then manufacturer of the CPU, like the Intel, they define in hardware level, define plus is this, minus is this, substrate is minus, and the move and so on. Shift. This number of operation, command, that is called instruction. Then instruction is defined in the CPU. That's the reason I program, okay, the AMD processor. Doesn't work with the Intel processor. The others are exactly same, but due to the difference of the CPU, it cannot. That's the true why, because each CPU has their own definition of this one. So may not understand. So this is the CPU. So what is the CPU? CPU is the processing instruction. It's a device, something chip that processing the instruction. Then, where's this instruction? Who provide that?
The user.
User. Where's the user?
Input.
User is not
Outside.
outside. So user just the code directly? No, not that. CPU unfortunately, main focus is the computation. One of your job is let me know the 10 minutes before class ends. So then, main job of the CPU is
Process instruction.
processing, not maintain this one. There are very small size of the area that keep this one is not big enough. So CPU need, a computer need the storage. Like the, for example, hard disk drive. Okay, hard disk drive or SSD, solid state disk, any storage. Then we can keep using one. As I mentioned, file system. File system, we can keep the instruction. Okay. Then CPU need to read such a thing, but main problem, CPU is so fast. At for example, 3.6 gigahertz. What does it mean? 3.6 gigahertz.
The number of
CPU.
Number of instructions.
Anyway, it's an electronic device. It's a cycle. The one cycle, it can process sometimes 2 cycles, sometimes 1 cycle need, okay, to process 1 instruction, depending on the complexity of the instruction. It can be 1 cycle, sometimes 2 cycles. Let's say 2 cycles. So, which means 1.8 gigatimes of the instruction can be processed. It's so fast. Okay, too many. Hard disk drive, very slow. So we cannot get the full benefit of this one. So to address, we have
Cache.
cache. This is very important considering the history of computer. Whenever we encounter speed problem in the computer, there are 2 different ways. One, we need to make the better algorithm, faster algorithm. Think about your complexity, the big O notation, something like that in your data structure. That's one way. Another way, hardware. Speed of hardware, but sometimes limited. At that time, we can use cache. I will mention the several times. Cache will have to speed up. Instead of accessing the data directly hard disk drive, we use the memory. Memory is faster than this. Okay? However, it's more expensive. So we cannot, nowadays it's getting cheaper, we only use the memory, okay, like the SSD as a hard disk drive. But still, this is the memory, so we can read the data to the memory. Okay, instruction from the memory. Then, actually the instruction is in the hard disk drive, then load copy to the cache memory, then finally going to the CPU. At the time, what is it called? From hard disk drive to the memory. Also, before that, where's the instruction?
No, it's in memory.
Right. These are the instructions. If you already took the assembly language, okay, you have seen. This is very, very hard to understand. Even I cannot do that. Some of the people can do it. So this is the very, very low level programming. Can you do that? It's almost impossible. Instead, we are using high-level program language, like the C, C++, Python, and such a program language, and then compile. Then this is the instruction. This is called program executable file. Then when you double-click, this will be copied to the memory. This is the process creation. Then this will be the first half of the semester. Operating system in charge of such a creating process and managing the process, because this is the, as you realize, most important part. Then pick up by the CPU, then the process each operation. Okay? So this is the first half. Then memory is also important. We need to manage such a memory. This is the second part of the semester. Then the last part will be, third part will be this hard disk drive, file system management. So operating system is in charge of to manage such a bunch of different device, yes, device and user. It is an operation. Okay. For whom? The last question. For what? We have computer. Who use this computer? User can be a person or it can be another computer. So user need to use this. In between computer and user, we need such a something, operating system. So in this class, throughout the semester, we will learn what is the main job of operating system and what kind of algorithm in this operating system, how they are working, and so on. Okay, any questions? So next class, we will continue the definition of operating system and it's kind of overview of the operating system before we start the meeting. Thank you.